So my name's Alvaru. I'm a software engineer at Bloomberg LP in New York City. And I'm here today to talk to you about a tool that my team built and some of the design that went into it. So at Bloomberg, I'm on a team that builds tooling and automation to make our infrastructure more reliable, scalable, and efficient. And without getting into too many details, a while back we were tasked with building a new tool. And the tool's purpose was to unify the existing tool set used by our operations teams. And in doing so, increase their repeatability and efficiency. So for this tool, we knew we wanted an API to host it, and we needed a CLI for individuals to interact with it. To achieve this, there's a fairly common pattern you might be familiar with. So on the left here, you have a REST API with various methods and paths. It speaks JSON. It's designed to be interacted with programmatically. On the right, you have a CLI made for human interaction, and it translates between the REST API operations into more human-friendly commands, syntax, and output. Usually these applications are tightly coupled, and the CLI is purpose-written specifically for the latest API spec. Now, from past experiences, we knew this design presented a couple challenges. We knew our API would have quite a few operations and might indeed never stop growing depending on the requirements of our infrastructure. And while building a tightly coupled API and CLI at first is easier, it presents a couple challenges as the project grows. Let's talk a little bit about why. So, a tightly coupled API and CLI is a simple and straightforward approach. The API is for programmatic access, the CLI is for human interaction, and the CLI code translates between the two. But when the API and CLI are tightly coupled, every time you modify one, you likely need to modify the other. You also need to continually maintain two separate code bases with different automation, deployments, and team knowledge. And the deployed API and CLI versions can get out of sync, and so you have to have synchronized deployments to avoid compatibility issues. So it was at this point that we had an idea. We were already planning on maintaining good API docs for other API clients. So what if the CLI commands were just based on the API documentation? With this model, the CLI would simply read the docs every time it starts and generate all its commands. So what would be some of the advantages of this approach? Well, when your CLI is auto-generated, new features and fixes only require an API change. And because of this, the API and CLI can never get out of sync. One big disadvantage is it's a lot more complex than a purpose-written CLI. And it should be noted that even with this design, you still have two code bases and you need to deploy a separate API and CLI. But the advantage comes from how this scales over time. In the beginning, the CLI and API will likely both be getting changed very frequently because they're under active development. But as the CLI matures, the API can still get continual updates with bug fixes, new features, etc. And the CLI should hopefully only require minimal maintenance. Effectively, at a certain point, you can stop deploying the CLI, but continue deploying the API, and the CLI gets updated for free. So we put together a first draft with simple one-to-one mappings between the API and CLI. API paths would map to space-separated CLI commands. Each path parameter, query parameter, and request body field would map to a single CLI flag, and the CLI would just print a JSON API response. We weren't the first people to think of this. You can Google it or ask your favorite LLM to do it for you. It's pretty straightforward. But let's look at the scheme in a little more detail. So here's a sample API endpoint that's used to list all the servers the API knows about. It uses a get method. Its path is /device/compute/servers. It takes an optional cluster name query parameter to filter results by cluster, and it responds with a JSON blob containing a list of found servers. Now, if we were to naively generate a CLI command for this endpoint, it would look something like this. To use it, you need to fully type out get device compute servers, specify your cluster with the --clusters_name flag, and you get back an HTTP status code and a huge JSON blob. If you can't already tell, this scheme leads to a bad CLI, and it's really not much better than just using curl. So we realized that simply bolting the API and CLI together with some simple mappings wasn't going to work. Doing so created a really poor user experience on the CLI. The problem is that good APIs and CLIs are designed for very different purposes. APIs are for programmers writing computer code, but CLIs are fundamentally a human interface. The underlying issue was that we were trying to map API concepts to the CLI domain, but REST API paths were never meant to be typed CLI commands. API parameter names were never meant to be typed CLI flags. And API response data usually is not meant to be consumed raw by humans. As we developed our first draft and ran into these issues, we kept trying to think up different ways to modify the API so that the directly mapped CLI commands would be more human-friendly. Perhaps we should just shorten our API paths so the CLI commands are easier to type. Maybe API path parameters could always be positional arguments on the CLI and not require flags. We had a couple more ideas like this, but ultimately we were looking at it in the wrong way. The end result would have been a bad API, a bad CLI, or both. If our CLI was going to auto-generate its commands from the API, we needed a translation layer to bridge the two. So then it occurred to us, maybe we can include this translation layer in our OpenAPI docs. The docs already contain all the basic information needed for a client to use the API. So why not include a little additional information on how to define the CLI interface to the API as well? So one problem we saw was that typing out a long API path as a CLI command is a lot of work for a human, and it's a pretty poor CLI user experience. Ideally, long API paths could be abstracted into succinct, intuitive CLI commands. So why not just have the docs define a specific CLI command for a given API endpoint? Then you go from this to this. Shorter commands mean less typing, but they're also cleaner and easier to understand. Another obvious problem was the API output formatting. REST APIs often speak JSON or some other structured language, but they usually aren't made for human consumption. And you can see that here. Even if we pre-printed this JSON, it's still not going to be easy for a human to read. So what if the docs include instructions on how to translate the JSON into something easier to read? Then you can go from this to this. And to accomplish this translation, but keep the API completely decoupled from the CLI, we use Jinja templates. If you're not familiar with Jinja, it's a relatively simple templating language with widespread use across the Python community. So the docs contain a server-defined Jinja template for each API endpoint, and the CLI simply has to pass the API response through the template to get the human-friendly output. Of course, there's a little more nuance to the output formatting problem. We also observed that CLI users often wanted the ability to display the same essential data, but in slightly different ways. For example, what if the user wanted the output here as a CSV file instead of the table shown? It would be kind of silly to have multiple API endpoints whose only difference was how the data was displayed to the CLI user, but we could have multiple Jinja templates for a single API endpoint and just give the user a way to choose between them. So we could have one template to display the output as CSV, triggered by the --CSV flag. Maybe another template just to show network information, triggered by the --net flag. And of course, all these options would be shown to the users in the command help text. You also might notice that --JSON flag there. We included that in all our commands, and it allows the user to get the raw API response and save it to a file or pipe it to JQ or something else. So another issue we noticed was how arguments were passed to the API. Originally, we planned on adding one CLI flag per API argument. But take a look at this getServer command, which was generated from the API endpoint code shown to the right. That --hostname flag isn't really buying us much. The API just has a single required argument, so it's just more for the user to type. So why not add the ability to make arguments positional? Like that. That's a very simple change, but it makes the command much more user-friendly. Staying on the topic of arguments, we noticed another unfortunate consequence of mapping API arguments directly to the CLI. It's handy in good code hygiene to have descriptive variable names in your code. Here on the right, we have an example API endpoint that collects logs for a given server and saves them to a location on a file system. To represent the log file destination, we have a descriptive variable called destination_filepath. While this variable might be helpful to programmers, it's an awfully long and cumbersome CLI flag to type. Not to mention that the use of underscores and flags doesn't really follow POSIX conventions. So why not have the ability to specifically define the CLI flag and short flag used to represent a given API parameter? Like this. Now, to specify the destination file path, you can use --dest path or just -p. Again, little improvements like this go a long way in improving the CLI user's experience. So the final problem we observed with API and CLI argument mapping was that sometimes arguments just couldn't easily be represented by a simple string on the CLI. For example, what if a CLI command needed to upload a local file? What about Boolean CLI flags whose simple presence represents true? What about list arguments with a fixed or dynamic number of entries? We knew we needed to build a dynamic system to represent unusual API arguments on the CLI in a human-friendly way. So now that you have a good understanding of the problem, let's look at how to implement it. We used many of the great open source projects you see here, but we're going to focus primarily on FastAPI. If you are familiar with FastAPI, it's a great open source web framework for Python. While there are numerous good reasons to use FastAPI, one feature we love is the built-in support for OpenAPI doc generation. Here on the left, we have a simple FastAPI implementation with 2 endpoints. With just this code, FastAPI automatically generates the docs you see on the right. However, what you see on the right is not exactly the documentation, but a pretty rendering of the actual documentation, which is defined in JSON and looks something like this. This JSON is the actual OpenAPI spec, and it contains all the information the client needs to know to call the API. As you can see, this JSON contains a section for each path in the API. This is what our CLI will be parsing to generate its commands. Now, let's look a little closer about how the OpenAPI spec defines an API endpoint. So here on the right, you can see the OpenAPI JSON generated for the getHello endpoint on the left. It contains a summary, a description of parameters, and a little more information than I left out for simplicity. For our use case, we need to define extra information for each API endpoint so the CLI can configure itself. So we just added a little section like this. Each endpoint gets a CLI section that can define things like the actual CLI command, the Jinja formatters, and more. Fortunately for us, FastAPI has a neat keyword arg called OpenAPI Extra. And it allows you to embed arbitrary information in the OpenAPI spec for an individual endpoint. And it's used like this. You just include your arbitrary object in the endpoint decorator, and it's automatically nested in the generated OpenAPI spec. Now we could just shoehorn a huge dictionary into every endpoint decorator to define the CLI spec, but that would be pretty crude and not very readable. So instead, we implemented our own child class of the FastAPI API router and just added some additional arguments so the CLI spec could be included. Something like what's shown here. And with that, we can define our API endpoints and associated CLI commands like this. We write our endpoints just like we normally would in FastAPI, but with the option of specifying a CLI command in just a few extra lines. Of course, you still need to define the specific Jinja templates to pretty print the CLI output, but in many cases, we found that different endpoints could use almost identical templates, and there were tons of opportunities for reuse. Now, we've now we've described how to set the CLI command for the endpoint, but we haven't really described the CLI arguments. I'm a little short on time, so I'm going to skip over how we do arguments, but it's in the slides, and I'm happy to discuss it after with you. So now that we have all the pieces to implement a CLI command for an API endpoint, let's put it all together. Here on the left, we have our endpoint from earlier that's used to get a list of servers. On the right, we have the CLI command that we want to be generated for this endpoint. To implement the CLI command, all you have to add is this. Just add a small amount of information about defining the CLI command, and FastAPI, OpenAPI, and our dynamic CLI take care of the rest. By now, hopefully you have a good understanding of the design and implementation, but I think a live demonstration is really helpful in showcasing the utility of what we built. I'm going to run through this quickly. I hope we got the one bug out of the way with the laptop, so this is going to go great. All right, so in this window, can everyone read that? Cool. In this window, we're going to run something called Infra API. It's a mock API I wrote to interact with infrastructure. It's running here locally in FastAPI, and it includes all that additional information I talked about to define a CLI for an API. In this window, we're going to run something called Infra CLI. Infra CLI is a toy CLI to interact with infrastructure. It's really just a front for Infra API running in the other window. Thanks. So every time I run Infra CLI, it calls out to Infra API, gets the docs, parses them, and generates the commands that you see here. So we've got a get server command to get a server by hostname, del server to delete a server, new server to create a new server, and list servers to display a list of known servers in the system. So, I got to turn a little bit so I can see this. It just changed when she hit that, but that's okay. So let's do list servers. So if we do that, that shows us a nice column-separated table of all the servers in the system. Let's check out the help text. So, display list of known servers in system. It's got a -- cluster flag to show only servers in a certain cluster. And it's got a couple formatters for JSON, CSV, and just network information. Great. So we get some feedback from our users, and they say, that list servers command is great, but it's too much to type. What if it was just ls servers? Okay. Also, there's some pretty glaring typos in the help text that you should fix. And lastly, the CSV flag is great, but what would be really helpful is a TSV or tab separated value flag. Okay. Let's see what it takes to make those changes in the CLI. All right. So this is going to be a little hard to do from this angle, but we'll see if we can do it. So I've got a couple source code files opened here. It's not important you read every line here. I'm going to breeze through it really quick. The important part is that it's just a couple lines to change. So here on line 72 through 90 something is where we define that API endpoint that's behind the list servers command. So you can see on line 73, that's the API path, device compute servers. And on line 76, we have the CLI spec for it. That's what's saying, for this API endpoint, this is the CLI command that we want. So we've got this help text, the command, and the formatters. So let's fix the typos here. Cool. We're going to change list servers to ls servers. And then lastly, for the formatters, we have to add another one. Now, the formatters are defined in another file. TSV is awfully similar to CSV. So we will just copy that one, name it TSV. replace all our commas with tabs. Ooh. Great. Let's change our flag to --tsv. Maybe we add a short flag, -t. Sure. And finally, the description should be display servers in the TSV format. Great. Lastly, we go here. We need to add it to the endpoint. And of course, we need to import it. It starts up, so we can assume it was hopefully bug-free. So let's go back to the CLI. Now, if you run infra CLI, the command is now ls servers. We check out the help text. The typos are fixed in the description, and now we have a --tsv flag. We try it out. We can pass our short flag -t. We see the same information in TSV format. The columns are weird because it's just raw tabs, but that's correct. Just to recap, we just changed 3 different things in CLI behavior by only changing the API code. The CLI code was completely the same throughout that whole thing. I want to show you one more thing. So in this window, we're going to run something called meal API. It's a mock API for interacting with meal ideas. Quick one that I wrote. It's also in FastAPI. It's also got the same information for defining a CLI. So let's go back here. Go meal CLI. Got commands just like infra API. It's got one called meals. List some meals. I don't really want to show you anything about that. Anything more about meal CLI. What I want to show you is that meal CLI and infra CLI are the same thing. They both are just a program called auto CLI pointed at a specific URL. Copy and paste is hard at this angle. So if I point auto CLI at meal CLI, you get meal CLI. If I just change the URL slightly and point it at infra API, you get infra CLI. That's one physical CLI code base for any number of logical CLIs you want to implement, depending on what API you point them at. And when you want to change the CLI, you just update the API and the CLI gets updated for free. That's all I got. Thank you.